All right, how has it been going so far? My impression is that we worked a long time to prepare till this 2-day conference, and now we are almost near the end of the conference. It's like, for me, the conference has been flying very fast. You have the same impression?
Yes.
That is a good feeling for me that I'm not an alien. All right, so this session is all about creating components for TMS WEB Core, so components that will run in your web applications and actually also in site kind of applications created from WEB Core, where in the previous session I was showing Miletus, the technology to create desktop applications with web technology. So the components that we are going to show, look at and build here in this session can, for example, also be used in a Miletus desktop application. So this is the agenda for the presentation this afternoon. We are going to talk about how to create non-visual components. That's quite easy, so we're not going to spend a lot of time on it. But we are going to spend more time on visual component creation in 4 different ways. And finally also how you register these components for the IDE so that they are available on the tool palette and you can use them at design time. And finally, some concluding component development tips and tricks. And the full source code of all the examples will be in the download afterwards, so don't worry if I go through the code maybe a little quick. Don't worry, you will get everything in downloads later on. So, first thing is, how would we create a non-visual component? Well, the good news is it's exactly the same way as you would do in a VCL framework or a FireMonkey framework. There is the T component class. You simply descend from T component. You override maybe the constructor of the T component class, and that's it. That class is immediately usable in a WEB Core application. You create an instance of that class, you use its methods, functions that you might have defined, and there's not much more to say. Everything you learned and you do in VCL, you can do in WEB Core. And now let's have a look at visual components, because although we tried to make it as similar as for a VCL component, we are running in a completely different environment, being the browser. So there are some differences, some things to take in account. And first thing that I wanted to explain or have a look at in some more detail is the component lifetime. Actually, let's start with the component lifetime in a VCL component. So the component class for the visual control is created. At that point, when you create that class, there is actually nothing that already happened in connection with Windows. So you just created a Delphi class that will eat up some memory, and that's about it. In the Delphi environment, your component only gets to life when there is a window handle created for your visual component. At that moment, the Windows messaging system starts to pop in. It will be able to paint itself, receive mouse, keyboard inputs, etc. So that's the window handle that is a fundamental thing for your component to come alive in a VCL component. Well, keep that in mind, because we have tried to bring this in the best possible similar way for a WEB Core component, and instead of a window handle, we talk in terms of an element handle. Why an element handle? Because everything in a browser, in the DOM of the browser, is built up of HTML elements. And so your visual control in a web core application, also in a similar way, only comes to life as soon as there is at least one HTML element that is in your DOM and through which things can start happening. The element can become visible and the element can start receiving inputs from mouse through JavaScript events, in this case through mouse, keyboard, get focus, lose focus, all these kinds of things. So if we talk about the component lifetime, similar as in the VCL, if you create a web core control, no life at all yet, you just create some memory object in your code, that's about it. It starts when either you set the parent, which is the same thing as you do in a VCL application, only when you set the parent there is a window handle being created. Well, here there are two possibilities, because WebCore offers the capability to hook up your visual component that you create, to hook it up to an existing HTML element already in your form template, or to create the HTML element itself. So that's a fundamental difference, and this difference is made by two possible constructors for your component class. So either you give it the owner, which is an object Pascal class, so to speak, or you give it an ID value, which is a string, and this is the unique element identifier of the HTML elements that you want as, let's say, the container control for your visual control, the container element, HTML element for your visual control. Okay? Is that concept clear? Actually, if you think from the perspective of a web core application developer, if you drop a component on the form, either you leave it as is, and that means that the owner will be the form, and that when your form starts running, this component is being created, owner is the form, and the component will create itself an HTML element. The type of the element is something that is specified in the component itself, but the main thing to remember is that at that point in time, it is the object Pascal class for your visual control that will create the basic HTML element in which the entire component will become functional. Opposite to when you're using an HTML template, and maybe you already have some HTML div element in your template, or an HTML table, an HTML canvas element, whatsoever. When you hook it up, your control on the form, to that HTML element that is in your template, then the control will create itself, wrapping that existing HTML element that is already in your template. It will not create a new element. You make that link between the control on the form and that existing HTML element in your template through the element ID property. That's what you do at design time. If you set that element ID property, what will actually be happening is that at that point in time it will call the constructor with the ID, the element ID of the ID that is in the template. Is that concept clear? Because I think this is really a fundamental insight to understand what's the lifetime of the control, and this major difference between a control that is created at runtime through a runtime created HTML element, or a control that is created and is bound to, is wrapping an existing HTML element in the form template. Question?
Ask myself, is it possible to mix this
So you mean
type that you have two components with ID,
so I understand your question as, is it possible to drop components on the form that will create themselves HTML elements on one side and other controls that you bind to existing HTML elements in the template? The answer is yes. So for every individual component on your form, you decide yourself, you are in control whether it is bound to something existing in a template or whether it will be newly created when your application starts. Okay? So you have the freedom of choice. Okay, so back to that HTML element, being either something created at runtime or something bound with, wrapped around some existing HTML elements in your template. How are we interacting with that HTML element? Well, we will want to react with it, obviously, via the mouse, via keyboard, touch it, and react to certain events that occur. Well, at this moment in time, we need to bind things to JavaScript events that happen on that HTML element. Because that's the fundamental basics of how in a web, in the browser DOM, you are getting notified that something is happening via user interactions with your HTML element. So what our T-Custom Control class is taking care of is that binding of all the standard JavaScript events that exist on an HTML element, and that is, for example, on click, on double click, on mouse down, on mouse up, on mouse move, on key down, on key up, etc. The T-Custom Control class already binds to all the JavaScript events that can happen on a specific HTML element. And so that is something that is happening in the process, the lifetime of your custom component. That is, okay, first get to the element, and then secondly, bind event handlers to that element. So the custom control is already doing a lot of the standard JavaScript events, but there might be on some specific HTML elements some JavaScript events that are not commonly used, commonly available, and then you can do custom binding. And to do that custom binding, the T-Custom Control class offers you two virtual methods. That is a bind events virtual method and an unbind event virtual method. You might ask, why is it important to also do unbind? Right, in JavaScript, well, if you do not unbind, well, first of all, an important difference is that HTML elements and binding JavaScript event handlers, it implements the concept of multicast events, which in Delphi, that concept does not exist. An event handler can only be coupled to one event. You cannot handle, you cannot have multiple event handler for a single event. In JavaScript you can. And so if you do not remove from a certain HTML element event handlers, maybe at some point in time, imagine an HTML element in your HTML template. At some point, if you don't remove it when your control goes out of scope, you end up with HTML elements in your template that maybe at some point in time have 200 event handlers that do not exist anymore because your the component itself, Object Pascal component, went out of scope. When the component Object Pascal class goes out of scope and your HTML element is still in the template, then of course you will get the JavaScript error, because there is still a binding between not longer existing code and the HTML element that is still there. So that's the reason why it's important when you do custom binding, always do also the equivalent unbind. So we are still in the lifetime of the component and the mapping of certain properties on the HTML elements. So if we want to change something in an HTML element, we manipulate, in fact, HTML element attributes or HTML element CSS style properties. Okay? So I give an example. There is a div element. Suppose that we are building a panel and we say we are happy with the div element as being the HTML element for our panel. That div element has CSS attributes for the border color, for the inner color, etc. It can even have some content. We can have the inner HTML of that div element where we can set some text, for example. So that means that if you have your component class with different properties to set the color, to set the text, to set the font, in reaction to setting the text, setting the color, setting the font, we will need to update specific characteristics of the underlying HTML elements. And that's why we have introduced the update element virtual method in the custom control class. And it is through that virtual method override that you can do your own custom mapping of certain component properties to, for example, CSS style attributes of the underlying HTML elements, or insert something in the inner HTML, etc., etc. We have split actually the update element virtual method into two underlying calls that you can separately also override, which is the update element data, update element visual. And I will immediately explain why we did it and why it makes sense to have done it. If everything that you have in your component properties, every change that happens, you change the border color, you change the inner color, you change the gradient, because CSS can also set gradients in elements, etc. These are visual things. Imagine though an edit control. That's the perfect example. If you have an edit control, the most typical thing you will want to deal with is the text value of your HTML input element. So we are talking here about the TWeb edit, for example, that will wrap around an HTML input element. And I think in most of the cases, you are fine with the color, or you set the color once and that's it. Most of the time, you will want to get the value or set the value, the text value of that HTML input element. If we wrap everything, every property that can change in one update element override, and for example, that update element override would do setting the CSS style property for the border, setting the border width, the border color, the border stroke, the fill, etc. You can see that it quickly adds up in numerous calls that you do in that update element override. And that's why we have offered to split this up. And if in the update element data, for example, there you will normally just deal with the text of your input element, because the other properties don't change. So that means that you do only one call to get to the input element value, get it or set it, and that's it. The other things don't change it, so no need to perform any calls. So these two methods exist, and they can you can do overrides to set your properties to specific HTML, CSS, and attributes. Other than this, there are, of course, in our standard T-custom control we are used to work with, numerous methods we are used to have, and where it is nice if it would be the same methods for the same kind of functionality in a web custom control. And that means that we have at custom control level implemented with the same method names these functions methods for the same functionality. So to, for example, show and hide a control, to bring it to front, send it to back, to set the focus, all these kinds of things we are used to in a VCL application. So we have introduced at the custom control level these methods. They are there, so you don't have to do anything special. You can keep using it as it is in the VCL. Okay, so for example, the procedure show in T-custom control. Think back about the example of the T-web edit that wraps around an HTML input element. And when the show method, what will it do underlying? It will use the CSS display property and set it to hide, or I believe it's display none will hide it, display without any setting will show it. So underlying what will be happening under the hood is when you call show, the CSS display property of that div element or HTML input element better will change. When you call hide, it will set that display CSS style property to none. But that's already all implemented at the custom control level, so you don't have to take care of that. Everything is already happening for you. And so let's now, for this session, I prepared actually 4 different ways to create a custom control in a web core application. And it will depend on your particular needs what the best way is to create your own custom control. So let's start with the first method, the first approach, which is to build a custom control that is most similar to what you are used to in the VCL. When you build a custom control in the VCL, you descend from the custom control, and you will basically do 2 things. You will make sure that the control renders itself, and you will want to handle user interaction, so via mouse, via touch, via keyboard, focus, etc. These things you will need to handle it to update the component, to invoke the behavior you want from that component. And so that is the first type of custom control in web core that we will demonstrate here in this session. The second one will be based on FNC, but I think it's best to first have a look in detail at how we can build such a custom control and look at that from the Delphi IDE. I'm not sure if that font size, is that, some want it still bigger, that font size? Or is that font size okay? Somewhat bigger? Bigger. I hear bigger the most, so I will make it a little bit bigger. Here we go. Okay, that's better. The example control, or 4 example controls that I created, are all calculators. So imagine you have a control, you drop it on the form, and you basically have a calculator on the form. And here, before we dive into the code of this custom control, the calculator, here you can see how we create that control at runtime. So we create a new instance of that class with the owner being the form. We set the parent to the form, and we specify a font name for that control. Maybe before we dive into the code, I'll simply run this example so that you can see already the results. So here's my web app, and from that button click, my calculator is created at runtime. And so if I do some calculations, you can see that it works, functions as a calculator. So let's dive now in the source code of how this calculator is created. As you can see in the users list, I have organized this in the calculator.pas file. And so this is the code for my calculator. And you can see that I descend here from TWeb custom control. And in the protected section, there are just 4 overrides that are virtual methods in TWeb custom control. Let's start with the rendering. So here, actually, I will start with the rendering, because it's important to note that TWeb custom control offers a custom rendered control. And that actually means that this TWeb custom control knows that it needs to create an HTML canvas element. That is, like in my previous example, I mentioned the HTML div element or HTML input element. For this type of custom control, it will create a HTML canvas element, because that HTML canvas allows us to perform drawing on that area. Okay? And so, to make that component render, I need to override the paint method. And if we inspect the code of the paint override, what you can see here is that basically I calculate the size of the rectangles that are the buttons in my calculator control. I need like 10 digits for all the numbers that I can key in, and then some functions like plus, minus, times, etc. So here I have the keys of my calculator, which is actually an array, a 2D array of the buttons that are on my calculator. And then simply in a loop, I have 4 buttons next to each other and 4 rows of buttons. What I do is draw a rectangle and draw the text for that button centered in that rectangle, and that's basically it. On top, this is the first line, and this draws the result, the value that is in my calculator, either what I have input or either the result of some calculation. But that's basically it. And here I determine the size of my calculator buttons, which is 1/4 of the width, because I need 4 buttons on a row. And here I have 5 rows, the first row being the row that shows the value. I show maybe the application again, so you can see good how this rectangle here, this is the rectangle, so we have 5 rows and we have 4 columns. Okay, is that clear? And now, what I do to interact with that control is to override, in this case, the mouse up and mouse down. The mouse up and mouse down, they will be received for the entire area that is my canvas HTML element, which is the container of my custom control. Why do I have a mouse down and mouse up? Because I actually store where the mouse was down, and only if the mouse goes up in that same area where it was down, I know that some button was clicked. Otherwise I could have clicked on 3, mouse down on 3, move my mouse to button 4 and leave it there. That's not considered a click on a button in my calculator. I'm saying here button, that might create a confusion because it's not a real button, it's this rectangular area that just functions as a button, okay? So here I keep a reference to what key was the mouse down on, and in the mouse up, if the up happens on the same key as where it was down, then I will call the process key method. And the process key is basically the method. Let me show you that method. Depending on the key, I need to do some operations. Either I'm still typing numbers, and the number I type in my calculator has to be added up, or I have performed a function, the plus, minus, times, etc. And when I have done an operation like that, and I press the equal sign, depending on the last operation, I perform here a sum, a subtraction, a division, or a multiplication. Okay, so that's actually, that has nothing to do with custom component development. That's just how the calculator internally, a simplified calculator, works like that. Maybe I can make it also even more clear by showing you the DOM. So this is the DOM, and as you can see, what I have here is the document body, and the only control that I have is the button element. Okay, my calculator does not exist yet. When I click the button, my calculator is created, and you have seen that this canvas element has been inserted in the DOM. It's at that point in time that my canvas can be painted on, that I can show you the calculator, and it's from that moment on that I can start working with my calculator. Okay. Is that process clear? Because I think this is the very basic first step. So before we go further, I think it's very important that everyone is still with us in this concept. Okay? Then we go a step further. We could also create our web core custom control by creating an FNC control. So we just implement an FNC control, knowing that if we develop against the FNC abstraction layer, what we develop will be usable everywhere. So actually, with one effort, I can create a calculator, and with that result, it will also work in VCL and FMX and LCL, and this is a web core presentation. Of course, it will also work in web core. And the technique that will be used in FNC will be actually almost the same as this example. The only difference is that I've coded against the FNC abstraction layer, and that my result will be usable in multiple frameworks, as opposed to the first example that is, of course, 100% specific to web core. So let's bring up the second example. Using that control is exactly the same. So I create again that calculator. I set again the parent and some font, and that's it. And it will look almost the same as the example directly in web core. So this is my FNC calculator, and so it works in exactly the same way. Let's have a look at the source code. It's in the same unit but in a different folder, calculator.pes. And as you can see, my processing of the mouse down, mouse up is also there. Actually, I copied the process key method from my first example, and I also copied the x to y methods. The only difference that you can see is these three methods, where you can see that paint has been replaced by draw, because that's the virtual method available in an FNC component to do your custom drawing. And the mouse down, mouse up virtual methods are here: handle mouse down, handle mouse up, which are the virtual methods in an FNC control to override that behavior. Other than this, it is actually the same. Of course, let us look at the implementation of the draw. You recognize that I also calculate the size of my rectangles. But what I'm doing, instead of dealing with a canvas in FNC, I'm dealing with here the TMS FNC graphics, which is the canvas but at FNC level. And so what I do here is, instead of canvas rectangle in a regular web core control, I do a graphics.draw rectangle, and we specify the fill, the background color for that rectangle. And where we have that variation between gray and light gray. One thing that I stepped over in the first example is the override for handle font changed. So similar to the VCL, where you have a common font property for your custom control class, if that font changes, your custom control class will call the virtual method handle font changed, because typically you will want to refresh your control because the font changed, it will look different, so it needs to be repainted. So all I need to do from handle font changed is call the invalidate method. In the handle mouse down, handle mouse up, I'm doing basically the same, because I just detect, is this a click, yes or no, on the same button, and that's it. The process key event is copy and pasted, so it's completely the same. So if I look at that result, I create it, and if we inspect the DOM actually, you will see that it's a slight difference here. The container HTML element for a FNC control is an HTML span, but still it needs to paint itself, hence we have this canvas HTML element sitting in the span. Okay, and so here I have some additional gimmick, that is that I give the background color for the place where I clicked a different color. And so this is my calculator in FNC. Same approach, subtle differences. Only major difference in result is that I can use that same calculator control also in a VCL application. And so let's move to somewhat more sophisticated, which is our calculator being built up of HTML elements. Because we are not going to custom paint the calculator anymore. No, we are going to create a calculator that is built up of a place where we can have text, and then real HTML buttons for each of the calculator buttons. And we will bind event handlers for clicking on each of these buttons in the calculator to perform our typical calculation functions. Okay? Maybe let's first focus on the result, see the result. And I will show the DOM here. So same situation, just a button in our HTML body element, and now I create my calculator. Okay, what do we see? That is that the outer element in this case is a HTML div element. Okay, but different now is that each button in my calculator sits in this HTML div element. All right, so that's now the major difference, and you can see that the content, the text on my button is set for each of these buttons in the calculator. Operational, it's exactly the same. When I perform a calculation, I need to press the equal sign, of course, like this, and you see that the calculator works the same way as all the others. Okay, so let's now see how this component is created, and I can tell it is created in a radical different way. And as you can see, the difference is already with the methods in the protected section that we did override. So what do we have? We have an override of create element. We have an override of create child elements. And we have an override of update element visual. So that means that is the method to use when only visual things change and will change the appearance of our custom control. It starts with the create element override. This create element function is being called, if you look at the lifetime of the component, it is being called at the moment that we need the real HTML element to appear in the browser DOM. Think about the same thing as you need at some moment a window handle to have a real Windows custom control. Okay, so create element will here in this case create our container HTML element. If you remember what I've showed, just the result in the browser, that will be the div element. Okay, so that brings our component to life, and what we have here is, as you have seen, a series of HTML buttons that sit in our div container element. And that's why I have this override of create child elements. That will be called when the control is ready for child elements to be created. Why is this different from, you could say we do everything in create element, right? But we will not always need create element, because in the scenario where your control is mapped on an HTML element that already sits in your template, it doesn't need to be created. It's already there. So this creation process is a two-step process. In case you have a fully runtime created control, that means it creates the container div element, and then in the second stage it asks, hey container, do you also have some extra child elements to create? If we would have bound our control to an existing HTML div that already sits in the template, create element will not be called. In the creation process, it will just link our object or object Pascal object to that HTML element in the template. And after that linking happens, it will call create child elements, because at that time it knows what HTML element to use to fill it up, in this case with the buttons. Okay, that concept is clear. So let's have a look at the code doing that. So here we have create element. That's very simple. It creates the div. And if we look at the HTML, the create child elements, that is what happens. We have, if you think about our calculator, we have two types of child elements that we will need. We need some child element for the area where the numbers are from our calculator as you type or the result. And we need buttons with which you can interact to type in and ask equal to perform the calculation. So that's why the first thing we do in create child elements is create that HTML div element for the numbers. We have also, that's a little bit specific, we are using CSS here to make sure that the buttons that I'm creating as the child elements of my container div element, we are using CSS display tricks to make sure that everything renders nicely as a grid. Because otherwise, if I would not do that, the buttons would just be stacked up in my div one after each other without in a grid structure. So that's something I force on another place, that is make sure that CSS will render the buttons in a grid structure, where in that grid structure I set the column span from my first div element that holds the value of the calculator to span the entire width of my container element. And I initialize here the value to 0. So that's the number with which the calculator starts up. And here you can see that my container element is the div element that is the container for all that I create inside. I perform the append child that inserts that div element into my container div element. And then I'm creating 16 buttons. Question?
Are there a CSS file or are these CSS styles?
At this moment, this CSS is set in code. It could also have been set via a property, the element class name. The element class name sets the CSS class for your outer container class. Okay? It could have been done this way. Here it is done, I will show it in a moment, in code, so that first of all you don't have to worry about it. Secondly, if you're unaware that the best way to render this is via CSS grid display, if you don't know this, well, it will be kind of tricky to get it right. Okay? That's why it's done here in code.
Okay.
Okay? And then I basically create 16 button elements and just append each of these button elements in my container HTML element. All right? I don't need to specify here column start and end, because my CSS says, okay, create a grid with 4 columns. Okay? And actually, if we have a look at, I believe it's here, remember that I talked about update element data, update element visual, setting my container div CSS hard-coded to display all the child elements in a grid structure is something visual. That's why I did an override of update element visual. And what I do here is set the CSS style of my container element to show it in a grid structure. Okay? And this grid structure can get very complex with CSS. That's some extra parameters to tell the CSS that all the columns in my grid should have an equal width and an equal height. That is the grid template columns that specifies that. Okay. Is that concept clear? Actually, now there's some other thing to do, that is, how are we going to handle the clicks on the buttons? And let me look up where this binding is happening. Actually, I forgot where exactly we do that binding. Although I'm...
The last line now.
Last line.
Ah, okay. Okay, it's done here. There are two possible approaches. As you have seen, I have created 16 buttons. What I could have done is, to each of these 16 buttons, I add an on-click event handler, okay? But I didn't do it this way. I did something smarter. What I did was override the handle do click element in the custom control class. So here, the handle do click. This event or this method is called whenever something is clicked. When the handle do click is called, it passes the mouse event parameter. That is the mouse event parameter is actually the JavaScript object that is sent along with the event that is triggered and contains a lot of information about what exactly happened, including the coordinates where you have clicked. But more importantly, here in this case, it also passes the event.target. And so that is in my container area that specifies what HTML element in that container was clicked. Okay? So the first thing that I do is test if that element is a real HTML element. So that's the base class from where the div, the button, the input, the canvas, etc. all descends. These are all HTML elements. So that's the first thing I do. I test if that is a real HTML element. Notice that then the next essential thing is, where is the creation of my buttons? Here. That's essential. I added to each of the button an extra attribute being a tag. And that's just to identify in a unique way all of the buttons that will sit in my container div in a grid. Okay? And in the handle do click, this event will be triggered also for the container, for the buttons that sit in my container, and I use the tag attribute. First of all, I check, is this having a tag attribute? Otherwise, if it would fail to call element.get attribute, and then I get the value as a number from that tag attribute, and then I call my exact same process key method as my previous examples, because also there I have this sequence of key values for my calculator. Okay? And so that's how, here in this case, the component is built up of different HTML elements. We go yet one step further. I first of all show the result. That's how it looks now. Okay, so what we actually did is same calculator, but just visually looking somewhat different. And in this case, we made it look different through Bootstrap, the popular CSS library for customizing the look and feel of your application. And so I enabled Bootstrap here. So if I open up Manage JavaScript Libraries, you can see that I have enabled Bootstrap version 5.2.3. Okay? And now in my calculator control, I will take advantage of Bootstrap styles that are available when I have linked this Bootstrap CSS library. And basically here is where the difference is. So Bootstrap has like hundreds of styles, and here I'm applying Bootstrap button style classes to the buttons that I create depending on the button that is being created. So this one will be a red colored button, this one will be a green colored button, that will be a blue color button, and that will just be light gray style button. But you can see that this is a possible way to link it up to an HTML and CSS library like Bootstrap. And let's run it again to see the result. That's how it looks like in the browser. And if we look at the HTML in the DOM, what you can see is these Bootstrap classes applied to the button elements. Okay, that's clear for everyone, because then we are going to a last example that gives us a calculator in yet another but entirely different way. And that is a calculator control that we built from an existing JavaScript library. So what I did was search the internet. It's full of open source JavaScript libraries of all kinds, and I've been just looking, is there some JavaScript library that gives me a calculator? Okay. And after some searching, I found one. I found multiple ones actually, and I played with multiple ones, but this one was one that kind of appealed to me. And so this calculator consisted of a JavaScript file and a CSS file. That was all that was involved, so I added it to my project. So my calculator becomes available as my project starts. To be honest, I have barely looked at the code for that calculator. So it's JavaScript open source from I don't even remember where. And the CSS that goes with it. Okay. I've actually, to get this calculator up and running, looked mostly at the HTML example that showed this calculator and dealt with this calculator. Okay, and from that HTML example, I built a control around it. Let's maybe first see the result of how this open source JavaScript calculator looks like. And here I'm creating it at runtime, and that's my calculator, okay? And so, yeah, I can do what you would expect to do to calculate something. You can see that here it nicely, it stacks up things of the calculation, etc. So that's a little bit extra that all came with that JavaScript library. So all credits go to the author of this library. I added some extra functions to hide parts of this calculator or show parts. Let's have a look how this calculator class was created. As you can see, what I did was introduce two properties, and these properties are used to control whether some parts of this calculator are visible or not. And then other than this, I only have the create element and the init method that are used in this custom control class. So in terms of size of control, I think this is really little. So what's happening here is in the create element, I create a container div. So this will be the div in which the calculator JavaScript library renders itself, deals with clicking on the buttons, calculating, etc., etc. And then I just do some initialization. And what the initialization basically is, here you can see, just a second, here. This is actually the JavaScript, the little JavaScript that is needed to initialize the calculator within the context of my container diff element. And that is a jQuery function where you pass here a JSON object, and that JSON object specifies some attributes of characteristics of my calculator. In this case, what this JSON attribute specifies is whether it shows the calculation history or whether it shows the bitwise operators, yes or no. There are some other parameters or characteristics you can control, but I've just exposed these two as properties. So what I do is I build a JSON object as a string to have this calculator being initialized. I turn this JSON as string into a real JSON object, and I pass it as a parameter to the function that initializes the specific open source JavaScript library this way. Other than this, I have to do nothing because all the calculation stuff, rendering stuff, etc. is all built into this JavaScript library. And here you see my two property setters for changing whether I want to show the bitwise operators or the history. What I basically do is just reinitialize. So I just remove everything from my container object and let it reinitialize with the characteristics I'm passing. Let's also inspect maybe the browser DOM as this happens. So what we see here is some spans for my checkboxes, okay, and then the button to create that control. If I now create the control, you can see that it creates the container diff, and within that container diff, that is all done, all handled by the JavaScript library. I didn't do anything myself here. So, as I said, I haven't even looked at the code for what exactly it's doing. It's just doing the job of having a calculator in your application. So these were 4 different ways, with one with some extra Bootstrap and the other not, to create custom TMS WEB Core controls. As you have seen in these examples, I have created all the controls at runtime. No need for a design time component here in this case. So if you want to create a component that is also available at design time, there is some extra work to do. What is actually needed is that you create a VCL stub class, and at the base, at the very minimum, this is just a VCL rectangle that you have on your form through which you can set some properties, okay? So what in this case for the calculator, the very minimum we can do is create a VCL control. And that's it. Just leave it as is. Maybe expose some properties like the bitwise and the show history property that we add to that visual VCL control, and register it as a VCL control in the IDE. To make it available on the tool palette when we have a WebCore project open, a web form open, we need to add this attribute here. This attribute is what we need to add on the VCL class. That instructs the WebCore integration in the IDE to make that class available on the tool palette when a WebCore form is open. There are some additional nice things that we can do. Imagine in the last case we have created this custom calculator using some JavaScript, CSS and some JavaScript file itself, so CSS and JavaScript. If you forget to include the JavaScript and CSS file in your project, obviously it will not work. So what we have also provided is the ability to register with the IDE that when you add this control on the form, it automatically needs to insert references to existing CSS and JavaScript files, so that otherwise, if you forget it, it will not work. If you register it, when you drop the component on the form, it looks at this GSLib reference attribute on your component. It scans the attribute for the links to be added, and they are added automatically to the project. So there is no more possibility to forget it. In this case, it will always work. I can show you that actually if with this example of the calendar that we created. So let's show our IDE. Here it is. Oh, that's the browser, of course. Okay. I'll start a new WEB Core project. Okay. If I look at the main project HTML file, you will see not much. So the only main reference to a JavaScript file is the project JavaScript file itself. And if I now add the web calendar component to my form this way, and now I go and open the HTML, you can see here I did nothing. I just dropped the component on the form, and these are two additional CSS and JavaScript files that were added to the project HTML. That's caused by here this trick on the slide with that GSLib reference attribute. We can also use this code in Visual Studio Code to add extra custom components. The difference here is that we don't need a VCL stub, because it will be the component itself that will be rendered live at design time on your form designer. The only thing you need is a DPK file where you add the pass file, and then you call register components just like you do for a VCL component, and with possible array of one or more classes that you want to register. And that same trick to insert automatically references to existing JavaScript or CSS files is possible, but here in Visual Studio Code you would do that via a custom editor that you register. In this case, the library requirements editor, where you override the requires libraries method. And here in this method you call proc with the links that you want to insert for specific controls. And then finally you register that requirements editor with your component class. And that is what Visual Studio will look at. What kind of design time editors for the requirements libraries do I have registered? When this type of control is dropped on the form, it will automatically insert the references to your project HTML file. And that's what I wanted to share this afternoon regarding WEB Core custom component development. Any questions in this area? Yes?
You do a visual component concerning more than one button, like your calculator. How can you map the Bootstrap ID to the single button from outside from the runtime?
So suppose we have this calculator to focus our attention. We have this calculator and we have 16 buttons in there. You have seen that now I have hard-coded the CSS classes that I set on each of these buttons. I understand your question that you say, how can I make it customizable at component level by the user to do that? Okay. Example, what we could do here is we have number buttons and we have calculator buttons. That could be one class to give all the numbers some style, to give the function buttons or calculator buttons another style. Okay, so we could add a property, number buttons, of the type T element class name, and we could also add the calculator buttons of the type T T element class name. And in the property setters, what we will do is, in the property setters, okay, update these CSS attributes for the number buttons to that setting and for the calculator buttons to another setting. In a nutshell, you write the code that maps whatever extra CSS attributes that you have added, maps it on the HTML elements that are a part of your control. Okay? There are other techniques, but then you could, for example, set specific attributes on components and then write your CSS in such a way that all components with that attribute will get automatically that CSS style. That's another approach. It depends a little bit on taste, I think, what kind of approach you would prefer. Other questions? No more questions. Then it's time for a break. And after the break, we continue with Holger for the last session of these training days.